Associate Professor from Postgraduate Department of Chemistry to today's session. Welcome, ma'am. On behalf of KST, on behalf of all the teachers and students fraternity, we would like to welcome you to this Talent Search Program webinar series. Before starting today's session, I would like to give a brief introduction about Dr. Geetha Pinto, ma'am.
ಉಮೇಶ್ ಸರ್ ಅವ್ರ ಲೈನಲ್ಲಿ ಇಲ್ಲ ಮೇಡಮ್.
No, she is there. She is there.
ಬಟ್ ಇಲ್ಲಿ ಇದಾಯ್ತಲ್ಲ ಸರ್ ಇಲ್ಲಿ.
No, we can see. Ma'am is there.
Is there, but is not audible.
Yes. Yes, muted. Ma'am, you can unmute and you can start your video camera also if there is no network issues. So before proceeding to next to the session, I would like to give a brief introduction about Dr. Geetha, madam. Basically, she is from Puttur and her early education is from St. Victor's Girls High School, Puttur, and later PUC from Vivekananda College, BSc Vivekananda College, Puttur, and MSc Mangalore University, Konaje. After that, she did her PhD in National Institute of Technology, Karnataka, Surathkal. The title of her thesis is Corrosion Inhibition Studies of 6061 Aluminum 15 volume PCT SiC composite in acid medium. At present, she is Associate Professor and Head of the Department of Postgraduate Studies and Research in Chemistry with teaching experience of over 6 years for UG and 15 years of PG. She is coordinator for many national seminars organized from the department. At present, she is the coordinator of Star College Scheme of St. Anne's College, a scheme by Department of Biotechnology, Government of India, and represented the college every year in the expert committee meetings held in New Delhi. This scheme is upgraded to star status now, and St. Anne's College is now one among the 2 colleges in India getting this status. She has published many research papers in national and international referred journals. She is a resource person for many invited talks organized for various students and faculty of UG, PG, and PU students. She has been recognized as a research guide by the Mangalore University. Currently, 2 students are working under her guidance. She has conducted many research projects, out of which minor research project sanctioned by UGC New Delhi and project sanctioned by UGC New Delhi. Both are completed. With this brief introduction, I welcome you once again, ma'am. Over to you.
Thank you. Thank you so much, sir. Thank you so much. I think because of the network issue, I will stop the video. And thanks for the opportunity given. I am grateful to KSTA for giving me this opportunity to take up the session on coordination chemistry. Let me share the screen.
The presentation you can see, ma'am, that you need to do that full screen only, slideshow.
Okay.
Yes.
Okay, let us start coordination chemistry. The contents of this presentation is introduction, types of salts, types of ligands, theories of metal ligand bonding, and their applications. When we talk about coordination chemistry, so we always think of coordination compound. So whenever we talk about coordination chemistry, we have to distinguish between the coordination compound and the covalent compound, because there is a quite very much similarity between the covalent bond and the coordinate bond. So when we talk about coordination bond and the covalent bond, so yes,
we are not able to see that full screen yet.
1 second.
The contents page you can see.
Screen is not there.
Okay. The slideshow icon you need to click on.
Stop sharing
Yes, ma'am. You can reshare, ma'am.
screen.
Meanwhile, request all the students to note down the presentation and mention if any questions or queries you get in between and type in the chat box. At
Can
the end of
you
the
see
session,
now?
you can see, ma'am, but not full screen yet. The single slide you can see. With this preview of the slides, all 1 to 5 and other slides also we can see.
Full screen you cannot
No,
see.
I cannot, ma'am. Move forward.
No, it is possible.
You can convert that slide into PDF and try to share.
Is it possible now? No.
No, ma'am, not yet.
This PowerPoint cannot be shared here.
No, it can be shared, but you can try the PDF. It will be very easy for the transition.
Yeah.
Are there any video and audio messages or animations
I
in
think
the?
animations will come with the PDF.
No, ma'am. In PDF,
I have
animations
given
are.
animation.
Okay.
Mm.
In that case, you better proceed with the presentation itself, ma'am.
Yeah. Mm. Yes. Now it is share. Okay. Now.
No, ma'am. We cannot see any presentation. It is not shared. Now it is coming. Now try, ma'am.
No.
Not yet, ma'am. Not yet. You're not taking the slideshow, ma'am.
Stop sharing. Once again, I'll be sharing. What is this? Screen.
What you can do is, ma'am,
Contents only. The site will be able to see the contents on the screen. Okay, select it. Share. Not coming.
your screen is shared now,
Yeah.
but
Full
the
screen.
presentation you need to open, then it will be seen, ma'am.
Opened. Presentation mode.
But your screen is shared, and we can see that Gmail and
I can see here full mode presentation.
I think
Insert.
in the share you have shared screen, but the presentation is not coming. The Gmail is open now.
It's not coming.
Not coming, ma'am. Otherwise, it will be okay, ma'am. You can share that presentation. Earlier, it was coming, right? The same way you can share it.
It was coming earlier.
Yes, ma'am. The presentation was coming, but not full screen mode.
Actually, in my laptop, it is full screen mode only.
Okay, ma'am.
No, I do not know how to get it there.
Stop share now and again reshare the presentation itself. Close the presentation now. Stop sharing and open the presentation. Then you start sharing the option by selecting that presentation. Then you can choose the slideshow.
Can you see now?
Yes, ma'am. Now it is fine, ma'am. You can
I
proceed.
know.
Thank you.
Okay. Thank you so much. Okay. So let us have the contents, introduction, types of salts. Good evening, students, those who are listening. Coordination chemistry is the interesting topic which is covered in inorganic chemistry. Now, when we talk about coordination compound, how to distinguish the bond, that is coordination compound is formed by coordination bond. Now, how to distinguish the bond, that is covalent bond and the coordination bond. Coordination bond is always called as coordinate covalent bond. So that means it is related to covalent bond. Now, how is it defined? The coordination compound is formed by the coordinate bond, or it is also called as complex compound. Coordination compound is also called as complex compound or complex salt. So what is the coordination bond? Now coordination bond is the bond shared by the two atoms, but sharing is contributed by only one particular atom. So when we talk about covalent bond is the bond formed by sharing of the electrons between the two atoms, but sharing is contributed by both the atoms, whereas in coordinate bond, sharing is contributed by only one atom. Normally, when sharing takes place, the atom or the group which is responsible for sharing the electron is called as ligand. Is called as ligand. Sorry for the disturbance. So here in coordinate bond, ligand plays the major role. So ligand is sharing its electrons to the metal atom. So this can be easily understood by giving an example. I will tell you the difference between the covalent bond, and the coordinate bond. I'll give one example. So covalent bond, we can compare it with two people, two friends going to the canteen and having a cup of coffee, but money is shared by two people. So if the coffee price is 2 rupees, 1 rupee is shared by one person and another rupee is shared by another person. Whereas coordinate bond, two people, two friends are going to the canteen. It is compared like that, going to the canteen and having a cup of coffee, but money 2 rupees is shared by only one person. So one cup of coffee, here also it is shared one cup of coffee, covalent bond also 1 cup of coffee is shared, but here money is given by 2 people, here money is given by 1 people. So in terms of electron, covalent bond is formed by sharing of the electrons between the two atoms, but sharing is contributed by both the atom, whereas sharing is contributed by only ligand. Ligand ಮಾತ್ರ electron ಅನ್ನು contribute ಮಾಡ್ತದೆ ಮೆಟಲ್ಗೆ, whereas metal electron ಅನ್ನು ಕೊಡ್ತಾ ಇಲ್ಲ. So sharing business is involved by only one particular group, that is ligand. So entire coordination chemistry is dependent on this particular uh, compound, that is ligand. So ligand word is familiar here, coordination compound. So you should know what is the meaning of ligand. So when we talk about ligand, ligand is the substance which gives a lone pair of electrons, a pair of electrons. If it is neutral, a lone pair of electrons to the metal atom. So ligand is a substance which gives a pair of electrons to the metal atom or metal ion in the coordination compound. So that is called as ligand. Now, if we talk about coordination compound in nature, if we talk about coordination compound, there are many coordination compounds which you can see in the nature. In the human body only, you can see coordination compound. You see, if I am talking today, it is because of this particular coordinate compound, that is coordination compound, that is hemoglobin. So hemoglobin, what is the role of hemoglobin? Hemoglobin transfers oxygen throughout our cells. Now, throughout the parts of the body, oxygen is supplied by this particular coordination compound. Now, this coordination compound, hemoglobin, this ion, which is in 2 plus oxidation state, it is bound to the ligand, that is nitrogen of the ligand part. We call it as porphyrin ring. So it is bound to 4 nitrogen part here. It is called as red blood pigment. So which is responsible for carrying blood. So this ion, 2 plus ion, if it doesn't form coordination compound with the nitrogen of porphyrin ring, if it doesn't form coordination compound, we cannot exist here, we cannot breathe. So here ion can be bound to again oxygen which we breathe, and this oxygen and the ion bond is coordination bond. Normally when we represent the coordination bond, we write the arrow inside the towards the metal ion. The arrow when you write towards the metal ion, it just indicates that sharing of the electron is by the ligand. If you see here another example, chlorophyll B. So here this is the plant pigment. The first one is a protein. This is the plant pigment where magnesium ion, the central metal atom, is coordinated with the nitrogen part of the ligand. So here is a coordination compound which is formed. Then you can see one more compound, that is vitamin B12. Here cobalt is coordinated with nitrogen, 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 uh, nitrogen atom. So here again the coordination compound is formed. So the ligands normally contain a pair of electrons which can be, sorry, arrow mark should be inside to the metal. So ligands are normally nitrogen, oxygen, then the halogens X. So these are all are having a pair of electrons which can be shared with the metal atoms. So here is another compound, that is an enzyme which is a coordination compound. Here copper metal is coordinated with the nitrogen. So here again, this is the coordination compound. These are all the coordination compound which exists in our body, that is inside the body. Now, if you see the coordination compound, or another name for that is complex compound, complex salt. So how many, this is same, coordination compound or complex salt is one and the same. Now, how many types of salts are there? One can be simple salt. You know, simple salt, if I ask the example, on the example ಕೊಡಿ simple salt ಗೆ ಅಂತ ಹೇಳಿದ್ರೆ ನೀವು example ಕೊಡ್ತೀರಿ. you can give the example of sodium chloride, you can give the example of potassium chloride, you can give the example of magnesium chloride. These are all simple compound or simple salt which exists in nature. Now coming to the second type of salt, a double salt. So what is the double salt? Double salt is the combination of two simple salts. Double salt is also a simple salt, but it contains two salts. So for example, if you combine potassium chloride and magnesium chloride, you will get uh, a fertilizer called potash fertilizer. So this is the double salt, or well-known example is potash alum, that is potassium sulfate is a simple salt, aluminium sulfate is a simple salt. When you combine these two salts, you will get the double salt. Now, the third type of salt is coordination compound, your complex compound, which we are discussing. So, what is a coordination compound? Coordination compound is the third type of compound. Just now I have shown the name itself suggests it is complex. Complex means here you can see simple salt and all. When you put sodium chloride in water, what happens when you put sodium chloride in water? It will be dissociated as Na plus and Cl minus. ಸೋಡಿಯಂ ಕ್ಲೋರೈಡ್ ಅನ್ನು ವಾಟರ್ ಅಲ್ಲಿ ಹಾಕಿದ್ರೆ Na ಪ್ಲಸ್ ಕೊಡ್ತದೆ ಮತ್ತೆ ಕ್ಲೋರೈಡ್ ಅಯಾನ್ ಕೊಡ್ತದೆ. ಸೋಡಿಯಂ ಅಯಾನ್ ಮತ್ತೆ ಕ್ಲೋರೈಡ್ ಅಯಾನ್ ಕೊಡ್ತದೆ. ಹಾಗೆ ಡಬಲ್ ಸಾಲ್ಟ್ ಹಾಕಿದ್ರೆ, ಡಬಲ್ ಸಾಲ್ಟ್ ಪೊಟ್ಯಾಷಿಯಂ ಸಲ್ಫೇಟ್ ಮತ್ತೆ ಅಲ್ಯೂಮಿನಿಯಂ ಸಲ್ಫೇಟ್ ಹಾಕಿದ್ರೆ ನಮಗೆ ಪೊಟ್ಯಾಷಿಯಂ ಅಯಾನ್ ಸಿಗ್ತದೆ, ಅಲ್ಯೂಮಿನಿಯಂ ಅಯಾನ್ ಸಿಗ್ತದೆ ಮತ್ತೆ ಸಲ್ಫೇಟ್ ಅಯಾನ್ ಸಿಗ್ತದೆ. ಈಗ ಕಾಂಪ್ಲೆಕ್ಸ್ ಸಾಲ್ಟ್, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ you can give any complex salt. For example, you can give potassium ferrocyanide. So when you put potassium ferrocyanide in water, you can expect potassium ion and cyanide. But when you put it in water, it will not give potassium ion, and cyanide ion, ferrous ion and cyanide ion. But instead, this is not observed, this is not observed. Potassium ion you will get, but you will get a complex salt. That is ferrocyanide ion you will get. Ferrocyanide ion, FeCN6 4 minus ion, ferrocyanide ion you will get. So you cannot dissociate into ferrous ion and the cyanide ion. So if that was possible, you know that potassium cyanide is the simple salt, isn't it? When you dissociate, new potassium cyanide ಅನ್ನು ವಾಟರ್ ಅಲ್ಲಿ ಹಾಕಿದ್ರೆ ಅದು potassium ಮತ್ತೆ cyanide ಆಗಿ ಕನ್ವರ್ಟ್ ಆಗುತ್ತೆ. ಈ LTT ಬಾಂಬರ್ಸ್ ಉಂಟಲ್ಲ, ಅವರನ್ನು ಪೊಲೀಸ್ ಹಿಡಿಯುವಾಗ ಅವರು ಈ ಪೊಟ್ಯಾಷಿಯಂ ಸಯನೈಡ್ ಮಾಲ ಹಾಕಿರ್ತಾರೆ, ಅದನ್ನು ಒಂಚೂರು ಲಿಕ್ ಮಾಡಿದ್ರೆ ಸಾಕು. ಈ ಸಯನೈಡ್ ಎಂಬುದು ನಮ್ಮ ಆಕ್ಸಿಜನ್ ನಾವು ತಗೊಳ್ತೇವಲ್ಲ ಬ್ರೀದ್ ಮಾಡುವಾಗ ಅದನ್ನು ರಿಪ್ಲೇಸ್ ಮಾಡ್ತದೆ. ಮತ್ತೆ ಈ ನಾನು ಈಗಾಗಲೇ ಹೇಳಿದ ಹಾಗೆ ಹಿಮೋಗ್ಲೋಬಿನ್ ಇಸ್ one of the coordination compound. In the hemoglobin, iron is bound to oxygen. So iron is responsible for carrying oxygen. Between the iron and oxygen, there is a coordinate bond. Once you lick the potassium cyanide, you know that it is highly poisonous. It is a simple salt. This cyanide, cyanide, ನಮ್ಮ ಆಕ್ಸಿಜನ್ ಅನ್ನು ರಿಪ್ಲೇಸ್ ಮಾಡಿ deadly poisonous it will be, because when cyanide is bound to iron will lose its capacity to bind with the oxygen which we are breathing. So that binding capacity is lost. Now no more oxygen. Potassium is bound to iron is bound to cyanide in hemoglobin and you cannot breathe. The person will die within a second. But if you take this complex compound, potassium ferrocyanide, see, look at the difference between potassium cyanide, which is simple salt, you take potassium ferrocyanide, K4FeCN6. So here it will be dissociated at potassium cyanide is dissociated as K plus and Cn minus. Potassium ferrocyanide is dissociated as K plus and ferrocyanide. So when ferrocyanide is present, you will not die, because this potassium ferrocyanide will not give rise to ferrous ion and cyanide ion. If it gives cyanide ion, then you will die. So this is the beauty of coordination compound or the complex compound. This complex compound, the beauty of complex compound is it will not be further, when you dissolve, it will not give its identity. It will not retain, it will, see, it will be dissociated at K plus ion and it will be dissociated at ferrocyanide ion. So they do not completely lose their identity, whereas here it will completely lose their identity. It will be K plus and Cn minus, whereas here it will be K plus and ferrocyanide ion. I hope you understood what is the difference between the simple salt and the coordination compound. So coordination compound cannot be broken down. So ferrocyanide is a coordination compound. I can write the coordination compound ferrocyanide as FeCN6 4 minus. So this coordination compound, when you put it in water, it cannot be dissociated into ferrocyanide and cyanide ion. Therefore, they do not completely lose their identity. Ferrocyanide you put, it will remain ferrocyanide only. So that is called as coordination compound. That means this cyanide ion has the capacity to bind the iron 2 plus ion with a very stronger bond. It cannot be dissociated. So the properties of coordination compound are different from that of the constituents. In the coordination compound, metal ion is surrounded by a number of oppositely charged ions. So, or neutral molecules. Number of oppositely charged ions can be ions. For example, if you take, I said the ligands can be, your water molecule can be ligand because oxygen is there. I said oxygen, nitrogen, etc. is a ligand. So ammonia is a ligand. But if you talk about halogens, halides are ligands, F minus, Cl minus, Br minus, because they have a negative charge. They have a pair of electrons which can be given to or shared between the metal. So sharing is contributed by the ligand. I hope you understand the coordination compound. Coordination compound ಗೆ ಮತ್ತೆ ಡಬಲ್ ಸಾಲ್ಟ್ಗೆ ಇರುವ ವ್ಯತ್ಯಾಸ ಏನಂತ ಹೇಳಿದ್ರೆ, ಡಬಲ್ ಸಾಲ್ಟ್ ಅಥವಾ ಸಿಂಪಲ್ ಸಾಲ್ಟ್ ನೀರಲ್ಲಿ ಹಾಕಿದ್ರೆ ಕರಗಿ ಅದರ ಅಯಾನ್ಸ್ ಕೊಡ್ತದೆ. ವೆರಾಸ್ coordination compound ಅನ್ನು ನೀರಲ್ಲಿ ಹಾಕಿದ್ರೆ ಅದರ ರೆಸ್ಪೆಕ್ಟಿವ್ ಅಯಾನ್ಸ್ ಕೊಡ್ತಾ ಇಲ್ಲ. ಅದೊಂದು ಕಾಂಪ್ಲೆಕ್ಸ್ ಕಂಪೌಂಡ್ ಆಗಿಯೇ ಉಳಿತದೆ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಪೊಟ್ಯಾಷಿಯಂ ಫೆರೋಸೈನೈಡ್ ಅನ್ನು ನೀರಲ್ಲಿ ಹಾಕಿದ್ರೆ ferrocyanide ion is called as complex compound or complex ion we call. That will remain as complex ion only. So it will not be dissociated as ferrous and cyanide ion. So with that, we will take some example and we will see which type of salt it is. If you take potassium chloride, so what is the type of salt? Potassium chloride. If you take, it is a simple salt. Potassium chloride is a simple salt. What about sodium chloride? Sodium chloride also simple salt, the first category. Magnesium chloride, simple salt. Why it is called simple salt? Because it can be dissociated into respective ion when you put in water. Magnesium and chloride, sodium and chloride, potassium and chloride. But if you take, ನೀವು ಈ ಎರಡು ಕಾಂಬಿನೇಷನ್ ತಗೊಂಡ್ರೆ ಪೊಟ್ಯಾಷಿಯಂ ಕ್ಲೋರೈಡ್ ಮತ್ತೆ ಮೆಗ್ನೀಷಿಯಂ ಕ್ಲೋರೈಡ್ ಅನ್ನು ತಗೊಂಡ್ರೆ ಅದು ಡಬಲ್ ಸಾಲ್ಟ್ ಆಗ್ತದೆ. ಬಟ್ ಪ್ರಾಪರ್ಟೀಸ್ ಆರ್ ಸೇಮ್. ಯು ವಿಲ್ ಗೆಟ್ ಪೊಟ್ಯಾಷಿಯಂ ಅಯಾನ್, you will get chloride ion, you will get magnesium ion, you will get chloride ion. It is already there. Okay, magnesium chloride also gives chloride. So this is called double salt because it is a combination of two salts. The properties are same. And what about this potassium? It is also double salt. It is a combination of two salts. It will give potassium ion, it will give sulfate ion, it will give aluminium ion. Then, if you take ferrous ammonium sulfate, that is called as salt. What it gives? Ferrous salt, sulfate ion, ferrous ion, sulfate ion, then ammonium ion. Sorry, yeah, NH4 plus ion. Then copper sulfate and ammonia. What happens? You take copper sulfate solution, dissolve in water, you will get a blue color solution. For that only, if you add ammonia solution, you will get dark blue color. So what happens when ammonia solution, ammonia is added to copper sulfate, you will get a complex compound called cuprammonium sulfate. So what is the complex there? Cuprammonium. This is the complex. So four ammonia ligands will be there. I said nitrogen containing are called ligand, and the copper central metal atom will be there. And outside the bracket, to neutralize it, cuprammonium sulfate is formed. So cuprammonium ion, that is 2 plus ion, is the complex salt. Then if you take ferrocyanide and add potassium cyanide, you will get potassium ferrocyanide as the complex compound. Just now I was explaining the difference between potassium cyanide and potassium ferrocyanide. So here is a complex compound. It contains ferrocyanide ion, that is FeCN6 4 minus and 4 K plus. So these are the different types of compounds. This is the simple salt, this is the simple salt, this is the simple salt, this is the double salt, double salt, double salt, this is the complex salt, this is the complex salt or coordination compound. Complex salt is also called as coordination compound. Now, little more about the ligand, types of ligand. So water, ammonia is a ligand because oxygen contains a lone pair of electrons. Ammonia, nitrogen contains a lone pair of electrons. Similarly, if you write methane, it is not a ligand because carbon doesn't contain a lone pair of electron. So your halogen contains lone pair of electron. The negative ion is acting as a ligand. Negative ion is responsible for the action of the ligand. Cyanide ion is a ligand. Sorry, thiocyanide is a ligand. Hydroxide is a ligand. Nitrite is a ligand. Then these are all called monodentate ligand because metal can bind to only one atom. That is oxygen atom here, nitrogen atom here fluoride, here nitrogen. So this is also called as ambidentate ligand because here sulfur is there. It has metal when it comes, it has ambiguity. ಅದಕ್ಕೆ ಸ್ವಲ್ಪ ಗೊಂದಲ ಆಗ್ತದೆ ಮೆಟಲ್ಗೆ ನೈಟ್ರೋಜನ್ ಒಟ್ಟಿಗೆ ಬೈಂಡ್ ಆಗುದು ಅಥವಾ ಸಲ್ಫರ್ ಒಟ್ಟಿಗೆ ಅಂತ ಲಿಗ್ಯಾಂಡ್ ಅನ್ನು ಆಂಬಿಡೆಂಟೇಟ್ ಲಿಗ್ಯಾಂಡ್ ಅಂತ ಕರೀತೇವೆ. ನೈಟ್ರೋಜನ್ ಒಟ್ಟಿಗೆ ಮಾತ್ರ ಬೈಂಡ್ ಆದ್ರೆ ಅದು ಮೋನೋಡೆಂಟೇಟ್ ಲಿಗ್ಯಾಂಡ್. So it can be considered as ambidentate ligand also. Then it is hydroxide, only one atom, that is oxygen. Nitrite ion, one atom, that is oxygen, monodentate ligand. Whereas, and here nitrite, again ambiguity is there, it can bind to oxygen or it can bind to nitrogen. So if it has ambiguity whether to bind with nitrogen or oxygen, then such ligands are called ambidentate ligand. Now what is bidentate ligand? Bidentate ligand means it is having two binding site, ಎರಡು binding site ಉಂಟು. ಇಲ್ಲಿ nitrogen ಇದೆ, ಇಲ್ಲಿ ಪುನಃ nitrogen. So it can bind, the metal can bind two nitrogen atoms. So it is called two sides. Therefore, it is called binding site. You can ask nitrite ion, there are two sides. No, why it is not bidentate ligand? Even though there are two nitrogen atoms, but it is ion minus which is responsible to form coordinate bond. This minus ion is responsible to form coordinate bond. So then here two nitrogen atom is there. So it is bidentate. Bi means two. Two sides are there. So you can write the metal and two sides are there to bind. Then here orthophenanthroline. So there are two sides. Oxalate, there are two sides. You can ask me, there are four sides. No, there are no four sides, but oxalate ion can be written as C2O4 2 minus. This 2 minus is responsible. So it is oxalate is like this. This is the oxalic acid COOH, COOH. If you remove H, it will be this side and this side which is responsible for binding. Then carbonate ion, bidentate ligand, this oxygen and this oxygen. That is two minus, which is responsible. It is formed by carbonic acid, that is CH2CO3. So when you remove H2 part of it, you will get CO3 2 minus. So 2 minus is bidentate ligand. 2 oxygen atom it can bind. Whereas polydentate, more than 2 sides are there for binding means it is called as polydentate. Here 3 sides are there. Diethylene triamine, 3 sides are there. Here you can see 4 sides. 1, 2, here 5 sides. 5 minus charges and 5 sides. Then here ethylene diamine tetraacetate. So you can see 1 nitrogen, 1 nitrogen, 1 oxygen, 1 oxygen, 1 oxygen, and 1 oxygen. So it can bind to 6 sites. So it is hexadentate ligand. So phosphate ion is 3 minus tridentate ligand. Now ambidentate ligand, as I was explaining, if the metal has ambiguity to combine, which uh, atom to bind. So here, if you metal comes, it has ambiguity. Now, metal can nitrite ion. If you take metal, can be bound to nitrogen as well as metal can be bound to oxygen. If you take NO2 minus, it can be bound to nitrogen and it can be bound to oxygen. So such ligands are called ambidentate ligand. Thiocyanate, it can be bound to sulfur or it can be bound to nitrogen. ನೈಟ್ರೋಜನ್ ಮತ್ತೆ ಸಲ್ಫರ್ ಮಧ್ಯೆ ambiguity ಉಂಟು ಮೆಟಲಿಗೆ. So it is called as ambidentate ligand. So thiocyanide also the same thing, it is ambidentate ligand. It can bind to carbon or it can bind to nitrogen. So next is the shape of the coordination compound. So here, if the coordination number is 2, it is linear. What do you mean by coordination number 2? If there are 2 ligands, then coordination number is 2. 2 ligands surrounding the metal ion, then coordination number is 2. Shape will be linear. If the coordination number is 4, it can be square planar or it can be tetrahedral. So it can be square planar or it can be tetrahedral. If the number of ligands surrounding the metal ion is 6, it can be octahedral. So let us discuss different shapes. Before that, let us discuss some of the theories of coordination compound. So first theory is Werner's theory. So it is given by the famous scientist Alfred Werner. He had given the Werner's theory, and the postulates are coordinate compounds have two types of valencies, primary valency and secondary valency. What is primary valency? Primary valency is given by the oxidation state. For example, if you take potassium ferrocyanide complex, so how do you find out the primary valency? Oxidation state. So how do you find out the oxidation state here? Now potassium, if you take, how to find out? It is 4 into 1. Potassium is +1 plus. You have to find out the oxidation state of iron. You do not know. Then cyanide, you know that -1. -1 into 6. -1 into 6. So overall charge is 0. So find out the oxidation state. 4 plus iron minus 6 is equal to 0. What is the iron oxidation state? Is equal to 6 minus 4. So iron oxidation state is +2. So primary valency is satisfied by the oxidation state of the metal ion. How to find out the primary valency? Like this you have to find. Now, the secondary valency is satisfied by the coordination number of the metal. What is the coordination number? Number of ligands which are surrounded, nearest neighbor we call, surrounding the metal ion is called coordination number. Now, if you take this particular compound, the number of ligands are 6 which are surrounding the central metal ion. So, coordination number is 6. So, what is the secondary valency in this? Primary valency is 2. plus 2, and the secondary valency is equal to coordination number. We found out that coordination number is 6. What is coordination number? It is the number of nearest neighbors, that is number of nearest ligands which are surrounding the central metal ion. So 6 ligands are surrounding the central metal ion. So coordination number is 6. Secondary valency is 6. So what are the limitations of Werner's theory? It has failed to explain why all the elements don't form coordination compound. And it has also failed to explain the directional properties of bonds in coordination compound. It does not explain the color. So if you take this particular coordination compound, cobalt chloride, if you add ammonia, this coordination compound is formed. If you add cobalt chloride 6 ammonia, this coordination compound is formed. If you add cobalt chloride 5 ammonia, this coordination compound is formed. Now let us see the example of 6 ammonia, first example, and the second example 5 ammonia. See, look at the color. So it is almost similar, isn't it? Only one ammonia is different. But look at the color. One is yellow color and one is purple color. So the Werner's theory doesn't explain the color of the complex compound. That is the drawback or the limitation of the Werner's theory. ಈಗ Werner's theory fail ಆಯ್ತು. So second scientist who has given Sidgwick theory. What is it? According to Sidgwick theory, central metal ion in a coordinate complex accept electron pairs from the ligands forming coordinate bonds. ಈಗ central metal ion ಉಂಟಲ್ಲ coordinate complex ಅಲ್ಲಿ they accept electron from the ligand and form the coordinate bond. So as a result, the demerit of this is large number of negative charges accumulate on the central metal ion. So when the large number of negative charge large number ಅಲ್ಲಿ accumulate ಆಗ್ತಾ ಹೋದ್ರೆ central metal ion negative ಆಗುತ್ತೆ. So which is not possible. Metal ion will be always positive. So this is also failure. Now let us go to the different modern theories of metal ligand bond. It is valence bond theory, crystal field theory, ligand field theory, and molecular orbital theory. We are not explaining ligand field theory. We are not explaining molecular orbital theory. We will be explaining valence bond theory and crystal field theory. Let us see what is valence bond theory. It is given by the scientist Linus Pauling in 1931. So according to him, the central metal ion or atom in the complex contain a number of vacant orbitals for bonding. So first and foremost condition, coordination bond ಆಗ್ಬೇಕಾದ್ರೆ ಮೆಟಲ್ ಅಲ್ಲಿ ವೇಕೆಂಟ್ ಆರ್ಬಿಟಲ್ ಇರ್ಬೇಕು, ಎಂಟಿ ಆರ್ಬಿಟಲ್ ಇರ್ಬೇಕು. ಸೊ ಆದ ಕಾರಣ ನಿಮ್ಮ ಡಿ ಆರ್ಬಿಟಲ್ ಉಂಟಲ್ಲ, ಡಿ ಆರ್ಬಿಟಲ್ ದೇ ಆರ್ vacant. So your d block elements ಇದೆಯಲ್ಲ, d block elements, they contain d orbitals. D orbitals, there are 5 d orbitals, so number is more. So your d block elements or f block elements, they have coordination compound normally because their number is more. So vacant orbitals ಅನ್ನ ಈ ಮೆಟಲ್ ಅಯಾನ್ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡಬೇಕು. ವೇಕೆಂಟ್ ಆರ್ಬಿಟಲ್ಸ್ ಅನ್ನ ಯಾಕೆ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ, ಆಸ್ ಐ ಸೆಡ್, the ligand compound. Ligands are the ions or the neutral molecule. They are sharing its pair of electrons to the metal. So whenever they share its electrons to the central metal ion should contain empty orbital. Empty orbital ಇಲ್ಲದಿದ್ರೆ ಇದಕ್ಕೆ ಶೇರ್ ಮಾಡ್ಲಿಕ್ಕೆ ಆಗುದಿಲ್ಲ. ಈಗ ಡೊನೇಟ್ ಮಾಡುವಾಗಾದ್ರೂ, ನಾವು ಮನಿ ಡೊನೇಟ್ ಮಾಡ್ಬೇಕಾದ್ರೆ ಒಂದು ಪೂರ್ ಪರ್ಸನ್ ಇರ್ಬೇಕು, ಅವರ ಹತ್ರ ಏನು ಹಣ ಇರಬಾರ್ದು. ಸೊ ಹಿಯರ್ ಆಲ್ಸೋ ಆರ್ಬಿಟಲ್ ಎಲ್ಲ ಫುಲ್ ಆಗಿದ್ರೆ ಅದಕ್ಕೆ ಶೇರ್ ಮಾಡ್ಲಿಕ್ಕೆ ಆಗುದಿಲ್ಲ ಮೆಟಲ್ ಒಟ್ಟಿಗೆ. ಸೊ ಮೆಟಲ್ ಆರ್ಬಿಟಲ್ ಎಂಟಿ ಇರ್ಬೇಕು. ದಟ್ ಈಸ್ ದ ಫಸ್ಟ್ ಅಂಡ್ ಫಾರ್ಮೋಸ್ಟ್ ಕಂಡೀಷನ್ ಟು ಫಾರ್ಮ್ ದ coordination compound. So if metal orbitals are not empty, then coordination compound cannot be formed. So the first and foremost condition is metal must have vacant or the empty orbital. So that is the first postulate. Second postulate, the number of vacant orbitals available is called coordination number. So whatever vacant orbitals are there, for example, if you take your first element 21, that is scandium element. If you take, it is a D1 system. The 4 orbitals are vacant. In D, 5 orbitals are there, only one electron is there. So 4 orbitals are vacant. So the number of vacant orbitals are called coordination number. That is the second postulate. Now, the third postulate is the appropriate atomic orbital, that is SPD of the metal, hybridized to give an equal number of new orbitals. So why hybridization? Because if you write the electronic configuration, there will be s orbital. If you write the scandium electronic configuration, you are writing argon, then you are writing 3D 1 and 4s2 and 4p0. So that means it is having d orbital, it is having s orbital, it is having p orbital. Now whenever the scandium loses its electron, scandium 3 plus ion, it will be 3d0, 4s0 and 4p0. Now when ligands are approaching, it is, it can see d orbital, it can see s orbital, it can see p orbital, or all are of different energy. So the first and foremost condition is, if there are different orbitals, they must undergo hybridization. What is the meaning of hybridization? Why hybridization is required? Because due to hybridization, all the orbitals energy becomes equal. Then the d orbitals involved in hybridization can be inner n-1d orbital or outer nd orbital. What is the meaning of this? What is inner n-1d orbital? For example, if you take 3D series, then the 3D series electronic configuration, just now I have written 3D and 4s, 4p, then 4D comes outer. So if these 3D inner orbitals are involved, then it is called as inner orbital complex, that is n-1d orbital. Actual outer shell is fourth one. So if this outer 4D orbital is involved, then it is called outer orbital complex. That is called as high spin complex. And inner n-1d orbital, if it is involved, it is called as low spin complex. Then a ligand has at least one orbital containing a lone pair of electrons. So one orbital must be there which contains lone pair of electrons. To designate any compound as ligand, it must have one lone pair of, minimum criteria is it must have at least one lone pair of electrons. Then when a vacant orbital of the metal and the orbital of the ligand containing lone pair of the electrons overlap, a coordinate bond is formed. I already said what is coordinate bond. Coordinate bond is the bond formed by sharing of the electrons between the two atoms. Which are the two atoms? One is metal and another one is ligand. But sharing is contributed by only ligand. Sharing is contributed by only ligand. It is just like having a cup of coffee, sharing the cup of coffee, but sharing is contributed, the money is contributed by only one person. It is just like that. The electrons are contributed by the ligand, that is called as coordinate bond. So the greater the extent of overlapping, stronger is the bond. And complex will be designated as paramagnetic complex if unpaired electrons are there, and the complex is designated as diamagnetic complex if there are no unpaired electrons. So this is the periodic table where these D block elements and the F block elements, I have not highlighted here, I have highlighted only D block elements, which are frequently forming coordination compound. Why? Because they provide empty orbit. What is the first postulate? Metal must provide empty orbitals for the ligand. When the incoming ligand comes and offers electron pair, metal must provide empty orbit. So your zinc if you take, cadmium if you say, mercury if you take, they are completely filled. Their empty orbitals are not. So it is difficult to form the complex. So this is the electronic configuration of scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper. So I have written the electronic configuration. Now when you talk about the valence bond theory, now valence bond theory can be applied to octahedral complex, tetrahedral complex. So first let us apply the valence bond theory, first theory, that is VBT. Let us apply to octahedral complex. So octahedral complex also, when we talk about, there can be, when how octahedral complex is formed, I said there should be 6 ligands. So 6 ligand means there should be 6 orbitals must be provided by the central metal atom. So what is the hybridization? D2sp3, or it can be sp3d2. This is outer d orbital. So outer d orbital involved, outer orbital complex, inner orbital is involved, then it is called as inner orbital complex. So this is the spectrochemical series where the strength of the ligands are mentioned. If you see carbon monoxide, cyanide, nitrite, and it, other ligands are weak ligands. So first example, let us solve this complex. Let us apply the valence bond theory to this particular complex, that is hexacyanoferrate 3 complex. So how to solve this problem? Now let us take the central metal ion, and before solving the problem, let us find out the oxidation number of the central metal ion. So how to find out the oxidation number of the central metal ion? So let us find out the oxidation number of the central metal ion. Fe we will write, we do not know. Then cyanide, we know that cyanide is En minus, so minus 1. There are 6 cyanide ions, 6, then minus 3. This charge is there, minus 3 is equal to 0. So it is equal to ion minus 6 minus 3 is equal to 0. So it is actually the complex ion. Wait a second. It is not the neutral complex, it is the anionic complex. So it is equal to minus 3. And how to find out the oxidation number? Fe is equal to minus 3. This minus 6 becomes plus 6. Ion is equal to plus 3. Oxidation state of ion is plus 3. So I will once again explain how to find out the oxidation state of the central metal ion. Fe, I have to find out the oxidation number, plus cyanide. The valence is cyanide, you write like this, is N minus, that means minus 1. Minus 1 into 6 cyanide ion, or that 6 is equal to the charge of this complex ion is minus. So Fe is equal to Fe minus 6 is equal to minus 3. Fe is equal to minus 3 plus 6 is equal to plus 3. So oxidation number of ion is plus 3. So I will write here Fe plus 3. So let us solve the problem. Let us apply valence bond theory to this particular complex. That is, what type of complex it is? Can you tell me? Students are there? What type of complex? ಯಾವ type ಇದು complex ಇದು? How do you find out the type of complex? It is octahedral complex. Why? because in octahedral complex there are 6 ligands. Octahedral complex there are 6 ligands. So I can write like this: Fe cyanide, 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 then cyanide, cyanide. So the total charge 6 minus, total charge is 3 minus. So total charge is 3 minus because it is Fe3 plus and 6 minus. So total charge is 3 minus. Now, how to do this problem? So let us fill. So iron 3 plus. So iron, if you see, I have written the electronic configuration. Iron comes here. It is 26. It can be written as 4s2 3d6. How do you write 4s2 3d6? So you will write the electronic configuration as argon, then 4s2 3d6. I'll fill 4s2 electron and 3d6 electron like this. So this is 4s2 3d6. Then I will write, how do you write? This is the electronic configuration of iron in the ground state. I do not want iron. I want iron 3 plus. I have already found out the oxidation state. So write the electronic configuration of Fe3 plus. So when you form Fe3 plus, what is the meaning of Fe3 plus? You are losing or removing or 3 electrons. So 3 electrons are lost. Whenever electrons are lost, the 2 electrons from the outer orbital and 1 electron from the inner orbital is lost. So first preference is for the outer orbit. So 3 electrons are lost. So how do you write the electronic configuration? So this 1 electron, not this 1 electron, these 2 electrons are lost, and the remaining is 5 electrons. Remaining is 5 electrons. So when the 6 cyanide ion approaches iron 3 plus, now the ligand. So we are forming the coordination bond. I have written here coordination bond. So when the 6 cyanide ion approaches iron 3 plus, what happens? This 6 cyanide, what is the first postulate? It must provide 6 vacant orbitals. 6 vacant orbitals. So it will provide 6 vacant orbitals. So it will undergo hybridization. So here what happens is how it will provide 6 vacant orbitals. This, see, you have to rearrange the electrons. The 5 electrons are there, no? This will be shifted here. So when this electron is shifted here, or this electron is shifted here, and this electron, these 2 electrons are shifted inside because they are singly occupied, no? They can be shifted. So the 5 electrons can be rearranged like this. 5 electrons can be rearranged like this. And you will get, since cyanide is the stronger ligand in the spectrochemical series, if you see the spectrochemical series which I have written, you can see that the cyanide is at the end. That means it is strongest ligand. So strongest ligand can pair up the electrons present in the orbital so that these electrons will go and occupy, they'll pair up. So actually 5 electrons are there, means Hund's rule of maximum multiplicity says singly occupied electrons. First, all the orbitals, available orbitals are singly occupied. Then only pairing takes place. But when the cyanide ion, the strong ligand approaches, these electrons gets paired up and it will provide. Now it has to provide how many ligands are there? 6 ligands are there. First postulate says, so how many ligands are there? That much vacant orbital must be provided. Now it is providing 2d orbital, 2d orbital and 1 s orbital, one s orbital, and 3 p orbital, 3 p orbital. So it is providing 2 d orbital, it is providing 1 s orbital, it is providing
Hello, ma'am. Hello. Hello.
ಕಾಲ್ ಮಾಡಿ ಕೇಳಿ ನೆಟ್ವರ್ಕ್ ಏನಾದ್ರು ಇಶ್ಯೂ ಆಯ್ತಾ?
Hello.
Are you there, ma'am?
Are you join, ma'am?
ಗೌಡ್ರೆ ಕಾಲ್ ಮಾಡಿ ಕೇಳಿ ಮೇಡಮ್ಗೆ.
Umesh sir. Hello.
ಹೇಳಿ.
ಸರ್ ಏನೋ ಫೋನ್ ತೆಗಿತಾ ಇಲ್ಲ ಅವರು.
ಟೆಕ್ನಿಕಲ್ ಇಶ್ಯೂ ಆಯ್ತಾ ಏನಾದ್ರು? ಹೌದಾ?
ಏನಪ್ಪ ಕಂಟಿನ್ಯೂ ಮಾಡ್ತಾ ಇದ್ರು ನೋಡಿ, ಈಗ ಇದು ಡಿಸ್ಕನೆಕ್ಟ್ ಆಗ್ಬಿಟ್ರು, ಅವ್ರು ಹೊರಗಡೆ ಬಂದ್ಬಿಟ್ಟಿದ್ದಾರೆ.
ನೋಡಿ ಏನಾದ್ರು ಎಮರ್ಜೆನ್ಸಿ ಇದೆಯಾ ನೋಡಿ.
ನಾನು ಕಾಲ್ ಮಾಡದೆ ತೆಗ್ದಿಲ್ಲ.
ಲೈವ್ ಇದು ಸ್ಟಾಪ್ ಮಾಡ್ಬಿಡಿ.
ಸ್ಟಾಪ್ ಮಾಡ್ಬಿಡ್ಲಾ?
ಲೈವ್ ಸ್ಟಾಪ್ ಮಾಡಿ ಮೇಡಮ್ ಇನ್ನೊಂದ್ಸರಿ ಫೋನ್ ಮಾಡಿ. ಬ್ಯಾಟ್ರಿ ಡ್ರೈನ್ ಆಗಿರ್ಬೋದು, ಇಲ್ಲ ಎಮರ್ಜೆನ್ಸಿ ಬಂದಿರ್ಬೋದು.
ಮೋಸ್ಟ್ಲಿ ಎಂಡ್ ಆಫ್ ದಿ ಸೆಷನ್ ಸರ್.
ಹೌದಾ?
ಹ್ಮ್.
ಇಲ್ಲ ಏನಾದ್ರು ಗೊತ್ತಾಗ್ಲಿಲ್ಲ ಕೇಳಿ.
ಇದ್ರಲ್ಲೇ ವಾಪಸ್ ಹೊರಟೋಗಿದ್ದಾರೆ.
ಇನ್ನೊಂದ್ಸರಿ ಚೆಕ್ ಮಾಡಿ ಮಾತಾಡೋಣ.
ಜಾಯ್ನ್ ಆಗಿದ್ರೆ ಜಾಯ್ನ್ ಆಗ್ಬೇಕಾಗಿತ್ತು ಇಷ್ಟೊತ್ತಿಗೆ. ಫೋನ್ ಪಿಕ್ ಮಾಡ್ತಾ ಇಲ್ಲ. ಉಮೇಶ್ ಸರ್.
ಟೆಕ್ನಿಕಲ್ ಪ್ರಾಬ್ಲಮ್ ಆಗಿರ್ಬೋದು, ಇನ್ನೊಂದ್ಸರಿ ನೋಡೋಣ ಇರಿ.
ಅಲ್ಲ.
ಎಂಡ್ ಅಂತ ಹೇಳಿರೋರು, ಯಾಕಂದ್ರೆ ನಾನು ಕೇಳ್ತಾ ಇದ್ನಲ್ಲ. Any alternate number to contact?
ಅವ್ರದ್ದು ಏನ್ ಜಾಯ್ನಿಂಗ್ ಪ್ರಾಬ್ಲಮ್ ಆಗೈತೆ ಪುನಃ.
Sorry for the inconvenience caused due to some network or other technical issues. We lost madam and we lost the connectivity with her. Wait for a few minutes. We'll try to communicate with them and we'll get back to you. Meanwhile, if any questions, please mention in the chat box.
Someone mentioned the chat box, sir. Please repeat the primary oxidation.
Primary oxidation calculation. Madam has repeated that, I think.
But now she left it, sir.
Once we speak with her and confirm, then it's better to end the session.
Umesh, sir. Hello.
Yes, tell me.
ಬಟ್ ಎಲ್ಲೂ ಇದ್ರಾಗ ಜಾಯ್ನ್ ಆಗಿಲ್ಲ ಸರ್ ಅವರು.
ಅಟೆಂಡೆನ್ಸ್ ಲಿಸ್ಟ್ ಅಲ್ಲಿ ನೋಡ್ತಾ ಇದೀನಿ ನಾನು, ಅಲ್ಲೂ ಜಾಯ್ನ್ ಆಗಿಲ್ಲ.
ನಾನು ನೋಡೋದು ಈಗ. ಮೋಸ್ಟ್ಲಿ ಅವ್ರಿಗೆ ಜಾಯ್ನ್ ಆಗಿದ್ರೆ ಸ್ವಲ್ಪ ಹಿಂಸೆ ಇದೆ ಸರ್. ಫಸ್ಟ್ ಟೈಮ್ ಆಯ್ತಲ್ಲ, ಹಂಗಾಗ್ಬಿಟ್ಟೈತೆ ಮೋಸ್ಟ್ಲಿ ಅವ್ರಿಗೆ, ಮ್ಯಾಮ್ಗೆ.
ಕೋಹಾಸ್ಟ್ ಮಾಡಿ ಬಂದ್ಬಿಡಿ, ನಂಗೆ ರೈಟ್ ಕ್ಲಿಕ್ ಮಾಡಿ ಕೋಹಾಸ್ಟ್ ಮಾಡಿ ಬನ್ನಿ. ರೈಟ್ ಕ್ಲಿಕ್ ಮಾಡಿ ಕೋಹಾಸ್ಟ್ ಮಾಡಿ ಅನ್ನ.
ಯಾವ ಕಡೆ ಸರ್?
ರೈಟ್ ಕ್ಲಿಕ್ ಮಾಡಿ ನನ್ನ ನೇಮ್ ಮೇಲೆ ಕೋಹಾಸ್ಟ್ ಮಾಡಿ ಇಲ್ಲಿ ಬನ್ನಿ.
ನಿಮ್ ನೇಮ್ ಮೇಲೆ? ಕೋಹಾಸ್ಟ್ ಅಲ್ಲ ಸರ್?
ಹೌದು,
ಮಾಡಿದೀರಿ ಸರ್.
ಅನ್ವೇಷಣೆ ಭಾರತದ ಸಿರಿ ಸಾಧನೆ ಶಾಂತಿ ಪ್ರೀತಿ ಸಂವರ್ಧನೆ ಕೃಷಿ ಕೈಗಾರಿಕೆ ಕಂಡು ಸಂಶೋಧನೆ ನಾಡ ಮುನ್ನಡೆಯ ನಾವೆಲ್ಲ ಒಂದೆಂಬ ಭಾವನೆ ಜ್ಞಾನವೇ ಶೋಧನೆ ಜ್ಞಾನವೇ ಸಾಧನೆ ಜ್ಞಾನ ವಿಜ್ಞಾನ ಸಂವರ್ಧನೆ ಜ್ಞಾನವೇ ರಂಜನೆ ಜ್ಞಾನವೇ ಪ್ರೇರಣೆ ನಿರ್ಮಲ ಬಾಳ ಉದ್ದೀಪನೆ ಜನಜೀವನವನ್ನು ನೂತನಗೊಳಿಸಿದೆ ಅನುಪಮ ಜ್ಞಾನ ವಿಜ್ಞಾನ ವಿನೂತನ ತಂತ್ರಜ್ಞಾನ ಕರುನಾಡನ್ನು ಪ್ರಗತಿಗೆ ನಡೆಸಿದೆ ಇಂದಿನ ಜ್ಞಾನ ವಿಜ್ಞಾನ ನಮ್ಮ ವ್ಯೋಮ ವಿಜ್ಞಾನ ಯುಗ ಯುಗ ಈ ಜಗ ಹೇಗೆಂಬ ಚಿಂತನೆ ಹೊಸ ಅಧ್ಯಯನಕ್ಕೆ ಪ್ರೇರಣೆ ತಂತ್ರಜ್ಞಾನದ ಶೋಧನೆ ಮಾನವ ಚರಿತೆಗೆ ಜ್ಞಾನದ ಬೋಧನೆ ವಿಜ್ಞಾನದ ಅನ್ವಯ ಧಾರಣೆ ಸಕಲ ಜೀವಿಗಳ ಸಂರಕ್ಷಣೆ ಜ್ಞಾನವೇ ಶೋಧನೆ ಜ್ಞಾನವೇ ಸಾಧನೆ ಜ್ಞಾನ ವಿಜ್ಞಾನ ಸಂವರ್ಧನೆ ಜ್ಞಾನವೇ ರಂಜನೆ ಜ್ಞಾನವೇ ಪ್ರೇರಣೆ ನಿರ್ಮಲ ಬಾಳ ಉದ್ದೀಪನೆ ಅನುದಿನ ಅನುಕ್ಷಣ ಹೊಸ ಅನ್ವೇಷಣೆ ಭಾರತದ ಸಿರಿ ಸಾಧನೆ ಶಾಂತಿ ಪ್ರೀತಿ ಸಂವರ್ಧನೆ ಕೃಷಿ ಕೈಗಾರಿಕೆ ಕಂಡು ಸಂಶೋಧನೆ ನಾಡ ಮುನ್ನಡೆಯ ನಿಶಾನೆ ನಾವೆಲ್ಲ ಒಂದೆಂಬ ಭಾವನೆ ಜ್ಞಾನವೇ ಶೋಧನೆ ಜ್ಞಾನವೇ ಸಾಧನೆ ಜ್ಞಾನ ವಿಜ್ಞಾನ ಸಂವರ್ಧನೆ ಜ್ಞಾನವೇ ರಂಜನೆ ಜ್ಞಾನವೇ ಪ್ರೇರಣೆ ನಿರ್ಮಲ ಬಾಳ ಉದ್ದೀಪನೆ
Sorry for the inconvenience caused. Due to some technical issue, we lost the connection with madam. Thank you for joining. On behalf of ASTA, I would like to thank Dr. Geetha Pinto ma'am and all the participants who have joined with us in this YouTube platform as well as in the WebEx platform. Thank you. We'll reschedule the same session one more time and we'll let you know the details when it can be rescheduled. Okay. Thank you. Thank you very much.